Starting Chapter 8 today, Lesson 8.1 is on 0 and negative exponents. The learning targets are I can simplify expressions with 0 and negative exponents, and I can evaluate exponential expressions. Hopefully at this point you have already completed the 8.1 0 and negative exponents activity that was in Schoology, and then hopefully you discovered some patterns. And on the next slide, we will go over what those patterns were that you should have discovered. All right, basically, one main property that we're talking about today is that for every non-zero number, if you take it to the power of 0, it will equal 1, no matter what that number is. So here is an example of 3 to the 0 power, it equals 1. Even a negative, as long as that negative is in parentheses, negative 2, all is to the power of 0, and that equals 1. It will work for any non-zero number. For any non-zero number, if you take it to, or if you take any number to a negative exponent, that is not 0. Then basically, in order to make that exponent be a positive, you have to move it to the reciprocal. So in this case, the negative exponent is in the numerator. Once it moves to the denominator of the fraction, the base just comes with it, and that exponent automatically becomes a positive. So our examples are 2 to the negative third, which could then be written as 1 over 2 to the positive third power, which would be simplified to 1 over 8. And then another example is negative 3 all to the negative fourth power. To make this negative exponent a positive, just rewrite that negative 3, that's your base, in the denominator now, and it becomes 1 over negative 3 to the fourth power. Notice I brought the parentheses along with it. And then remember what that means is that you are actually taking negative 3 times itself 4 times. And that's where the 1 over 81 comes from. And again, hopefully all of that was discovered in the proof activity that you did in Schoology. So now let's do some examples. If we want to just simplify 4 to the negative third power, we can write that as 1 over 4, and the 3 is now positive because we moved 4 to the denominator. And the same thing, 3 to the negative fourth power, to make that exponent become positive, write it as 1 over 3 to the positive fourth power. And then negative 1.23 to the power of 0, that's just 1, because again, anything to the power of 0, any non-zero number to the power of 0 equals 1. Why don't you go ahead and try the next 4 examples, hit pause, try them on your own, and see if what you get for your answer matches what I get. All right, here are the answers. You'll notice in this top section I also did go back and I simplified a little bit further those fractions. So 1 over 4 cubed becomes 1/64th, and that just comes from 4 times 4 times 4. And then 1 over 3 to the fourth power simplifies all the way to 1 over 81. Take a look at the last 4 examples and make sure you have those answers. Notice it gets kind of tricky sometimes to work with those negatives. There is a difference between when the negative is in parentheses, then that's the base, and when the negative is not in parentheses, then it's only the 3 that's being squared here, and then that negative just gets attached at the very end. Okay, read through, and it says an algebraic expression is in simplest form when it is written with only positive exponents. If the expression is a fraction in simplest form, the only common factor of the numerator and denominator is 1. That's just regular simplifying fractions. But right here, we're reminded that everything has to have a positive exponent. So if there's a negative exponent, you need to simplify it. And the way we simplify it is by moving it to the denominator, or its reciprocal. So for 4y x to the negative third, the only part of that expression that has the negative exponent attached is the x. 4 and y are both to the first power. So 4 and y can stay in the numerator, and then x moves to the denominator, and that exponent becomes a positive. Always look to see if you can simplify it any further. We can't. So 4y over x cubed. In the next one, 11 can stay in the numerator. M has that negative exponent attached, so it becomes m to the fifth in the denominator, and it can't be simplified anymore. And in the last one, 1 is in the numerator. It can stay there. W to the negative fourth should move to the numerator because it's a negative exponent in the denominator, so move it to the numerator and it becomes a positive. So 1w to the fourth, or just plain w to the fourth. Try the last three on this page on your own. Press pause and then come back and see how you did. All right, how'd you do? For this one, the m to the negative fourth was the only one that had to move to the denominator. Everything else got to stay in the numerator because it was a positive exponent that was attached to it. In the second example in the bottom row, 2 gets to stay in the numerator. A has to move to the numerator to make it a positive exponent. And then in the last one, the end of the negative fifth actually has to move down here to the denominator, making it a positive exponent. And y squared can stay in the denominator because it's already a positive exponent there. And when there's nothing left in the numerator, you have to have something there. You would never just leave this blank. So we always write a 1 if there's nothing else left in the numerator. Next, we're going to evaluate. So we are evaluating 3m squared n to the negative second when m is positive 2 and n is negative 3. So the method 1 is to just write this expression all with positive exponents first. So that would look like this. 3m squared over n squared. And then you would actually substitute these values for m and n into your new expression. So that would be 3 multiplied by 2, which is squared, over n, which is negative 3, and that is squared. And then just follow order of operations. So this would become 3 times 4 over positive 9. Negative 3 times negative 3 is positive 9. And then 3 times 4 is 12. 12 over 9 reduces to 4/3, or 1 1/3. The second method is to actually just substitute first. So we're replacing that original expression. 3m is now being replaced with 2. So 3 times m squared is 3 times 2 squared times n. N is negative 3. And that is to the negative second power in the original expression. So now you can just evaluate. And again, if we worked with the exponents first, this would be 3 times 4. And then this expression, negative 3 to the negative second, we'd have to make that a positive exponent by moving it to the denominator. The negative 3 still stays, but the negative 2 exponent becomes a positive. And then this would simplify to 12 over negative 3 squared is 9, and again it reduces to the exact same thing. So whichever method you prefer is the one you should use. All right, use either method, method 1 or method 2. Substitute right away or move those negative exponents around and simplify the expression first, and then use substitution. Press pause, come back and check, see how you did. Go ahead and check your answers, see how you did. All of the work is shown here, so if you need to, press pause, take a closer look at the work. Couple things that kind of stand out for me are just making sure that, especially when there is a negative that is being squared or cubed, or a negative to any power, like when you were replacing n with -2. In this third example, when I moved n to the denominator and it became n cubed, when I replaced n, I use parentheses, and it makes a difference sometimes. It wouldn't necessarily in this one, but it does make a difference sometimes if you forget to use those parentheses and you were supposed to. That -2 is all being cubed, so it really should be in parentheses there, and it still maintains the negative. It's 1 over -8 there. Let me know tomorrow or email me if you have any questions on these, and good luck with your homework assignment.